Good morning, students. Today we have to do the laws of exponents for real numbers. Let a greater than 0 be a real number and let p and q be rational numbers. Then let us take the first law of exponents. Though you have done the laws of exponents in your junior classes and laws are same, but now we have extended these laws to the real number system. See the first law, which says that a raised to the power p dot a raised to the power q, here dot means multiply, is equal to a raised to the power p plus q, which means that if we have two numbers in multiplication whose bases are same, then what we can do? We can add their powers. Let me repeat. If there are two numbers in multiplication whose base is same but the powers are different, then we can add those powers. A raised to power p plus q. Let me explain it with the help of an example that how to apply this law. So let me have a number 2 raised to the power 2 by 3, which is in multiplication with another number 2 raised to the power 1 by 3. You can see that the base is 2 for both the numbers and we can apply this first law of exponents. So this is equal to 2 raised to the power 2 by 3 plus 1 by 3. Because the powers are now rational numbers, so obviously you need to take LCM to solve them. 3 is the LCM here. This is 2 plus 1, which is equal to 2 raised to power 3 by 3, which is equal to 2 raised to power 1 or simply 2. So you can see that by using this law, I have simplified this question. Now similar to the first law, we have the second law. Here, if the bases are same and two numbers are in division, then instead of adding, what we do, we subtract the powers. That is a raised to power p divided by a raised to power q is equal to a raised to the power p minus q. This is again a law which we have done for rational numbers. Now we are extending this to the real number system. Let us apply this law to an example, that is 7 raised to the power 1 by 5 divided by 7 raised to the power 1 by 3. Now you can see that the two numbers are in division and base is same for both of them. So let us apply this law, which says that this is equal to 7 raised to the power 1 by 5. Here p is 1 by 5 and q is 1 by 3. So p minus q means 1 by 5 minus 1 by 3. Let us take the LCM. So LCM of 5 and 3 is 15. Now here 15 divided by 5 is 3. So I get 3 here minus 15 divided by 3 is 5. And 5 multiplied by 1 is again 5. So this is 7 raised to the power minus 2 by 15. After subtracting, we are getting this. It is simplified, and if you want to make the power positive, I can write like this: 1 by 7 raised to the power 2 by 50. So this is simplified. Now let's move to the next law. Now let's see the third law. If I have a number raised to the power p and outside the bracket there is another power q, it means for the same base, if we have two different powers, then we can multiply those powers. So a raised to power p raised to the power q can be written as a raised to power pq. We can take the product of the powers. Now Let us understand it with the help of an example. The example is, if I have 3 raised to the power 1 by 5. Say P is 1 by 5 and Q is 4. So applying this law, what I'll do? I'll multiply 1 by 5 by 4. So finally this is 3 raised to the power 4 by 5. Now let us see the next law, that is fourth law, which says that a raised to the power p multiply by b raised to the power p is equal to ab raised to the power p. So here you can see that bases are different and two numbers are in multiplication, but power is same. So if bases are different and power is same, we can take the product of these two numbers and we can keep the power only once. So let us take one example for this. Example is 13 raised to the power 1 by 5 into 17 raised to the power 1 by 5. So here the power is same in both the numbers, that is 1 by 5, but bases are different. So I can use this law and I can multiply these two bases. Here A is 13 and B is 17. And this is raised to the power 5. Now we can find the product of A and B. So 13 multiplied by 17 gives you 221 raised to the power 1 by 5. Now children, let us take some extra questions based on these laws of exponents which are not there in the NCERT. In NCERT you have only a small exercise 1.6 in which you have very simple questions which you can do on your own. Let me take some different questions which come in the exam based on laws of exponents. The first one is, find the value of x if 2 raised to the power 5x divided by 2 raised to the power x is equal to 5th root of 2 raised to the power 20. Now here in LHS you can see we can apply the second law. Here bases are same and so we can subtract the powers. So this is 2 raised to power 5x minus x. I have applied the law here. Here what we can do? 2 raised to the power 20. You know that if it is 5th root, I can write it like this, 1 upon 5. Like square root we write half, cube root we write 1 by 3. In the same way, if it is 5th root, I can write it as the power 1 by 5. Now here what we get? 2 raised to the power 5x minus x is 2 raised to the power 4x. Now again we can apply a law here, which is your third law, because there are two different powers. So what I can do? I can multiply those powers. So 20 multiplied by 1 by 5. On cancelling it, I will get 5 into 4, 20. So let us write it in the next step. 2 raised to the power 4x is equal to 2 raised to the power 4. Now, as the bases are same, we can equate powers. You have to write one statement here that as the bases are same, we can equate powers, which implies 4x is equal to 4 and which further implies that x is 4 upon 4, that is x is 1. So this is how we have found the value of x in this problem, and two laws we have used, one on LHS and the other one on RHS. Let us take another problem. Here we have to prove that 3 raised to the power a divided by 3 raised to power b in the bracket raised to the power a plus b multiply by 3 raised to the power b divided by 3 raised to the power c in the bracket, and the power is b plus c. Similarly, we have the third expression, and all three terms are in multiplication, and you have to prove that the whole expression equals 1. So to prove this, we need to apply the laws of exponents. Now, as you can see in the bracket, we have 3 raised to power a, 3 raised to power b. As the bases are same and the numbers are in division, we can apply the law that if the bases are same, we can subtract the powers. So let us use that law here. Okay, let us take LHS only right now, and we will prove that it is equal to RHS. In the bracket, I can apply this law that 3 raised to power a minus b, as bases are same and we can subtract the powers. And the outside we have this power a plus b. Similarly, children, here also you can see that the bases are same, numbers are in division, same law can be applied again. So here we have 3 raised to the power b minus c inside the bracket, and outside we have the second power b plus c. And another term we have in the similar way, 3 raised to the power, here c and in the denominator it's a, the numbers are in division, so I can write 3 raised to the power c minus a inside the bracket, and outside I have c plus a. So same law I have applied 3 times. Now we need to apply the second law here. Another law means we have one power inside and the other power outside the bracket for the same base 3. So now what we are going to do, we can multiply these powers, like 3 raised to power a minus b multiply by a plus b. Similarly, 3 raised to the power b minus c multiply by b plus c. And third one is 3 raised to the power c minus a multiplied by c plus a. Now you can see that we have this identity, a minus b into a plus b is a square minus b square. So we can use this identity here. So 3 raised to power, using identity I get a square minus b square. As we have similar terms, same way, same identity I can apply here also. So b minus c, b plus c becomes b square minus c square. In the same way, use the same identity here, c square minus a square. Now children, you can see that the terms are in multiplication and base is same, so we can add powers. So 3 raised to power a square minus b square plus b square minus c square plus c square minus a square. If you have observed carefully, you can see that a square, one of the a square is positive, other one is negative, so it can be cancelled. Same way, one negative b square, one positive, one negative c square, other one positive. So if we have a positive term and the negative term, and if they are same, we can cancel them. So finally I got 3 raised to the power 0, and this is again another law which you already know, that any number, here we can say that any real number raised to the power 0 gives you 1. So using this law, I can write it as 1. Now this is equal to our RHS. So we have proved that LHS is equal to RHS, hence it is verified. Let us take one more example, children. In this, the question is to simplify this expression, and this we are going to do again by using laws of exponents. Here you can see 81 divided by 16. 81, if you make its factors, you will get it is 3 raised to the power 4. Similarly, 16 is 2 raised to the power 4. So, I can write it in power notation, that is 3 by 2. Because 3 multiplied by 3 is 9, then 9 multiplied by 9, 81. So, this is 3 raised to the power 4. So, I can write it like this, 3 by 2 raised to the power 4, and let us multiply it by the power which is given outside. And whenever there is a negative term, you have to keep it in the bracket. Let us proceed further. Now, inside this big bracket, again see 25 is the square of 5. Similarly, 9 is 3 square. It means I can write like this, 5 upon 3 raised to the power 2. And already we have one power outside, so I can write it in multiplication. Now, this is divided by, see children, whenever we have some negative power, I can reciprocate it to make the power positive. So, let me write it as 2 by 5 raised to the power 3. Because I have changed this negative power to positive one by simply reciprocating. You can see that this 4 can be cancelled with this 4. Similarly, 2 can be cancelled with this 2. And let us write the next step, which is 3 by 2 raised to the power minus 3. Multiply by 5 by 3 raised to the power minus 3. Now to change this divide sign into multiply, again I can reciprocate it like this. I have changed this divide into multiply. So 5 by 2 raised to the power 3, and brackets close. Now let us make the power positive here. So reciprocated, 3 by 2 becomes 2 by 3 raised to the power 3. And inside the bracket also I can I can reciprocate it, and I can write it like this, 3 by 5 raised to the power 3, and multiplied by 5 by 2 raised to the power 3. Now let us open these big brackets, and you can see here this is 2 raised to power 3 divided by 3 raised to power 3. Similarly, here I have 3 raised to power 3 divided by 5 raised to the power 3. And the third one is 5 raised to power 3 divided by 2 raised to power 3. Now, as you can see that these are similar terms, so these can be cancelled. So all the terms are getting cancelled, and finally the answer is 1. See the next question, children. We have to prove this expression is equal to 31 upon 145. Now, what can be done first of all? Always remember that we can take some terms common. So here 5 raised to power 26 can be taken common in the numerator. Let us take the LHS only first of all. LHS we will solve, and then we will prove that this is equal to RHS. Now in the LHS, I can take 5 raised to the power 26 common. Here I have 5 raised to the power 28. So it means 5 raised to the power 2 is left. Because when you are going to combine these terms by the laws of exponents, 26 plus 2 becomes 8. Similarly, plus 5 raised to power 27. 26 times I have taken common, so only 5 raised to power 1 is left. And here I have taken the whole term common, so 1 is left. Similarly, in the denominator, I can take 5 raised to the power 27 common. If it is common, then here it can be written like this, 5 raised to power 2, because 27 plus 2 is 29. Then second term here is 28. 27 times we have taken common. So I have 5 raised to power 1 left here, and here I have minus 1 because 5 raised to power 27 has been taken common. Now children, this is further equal to 5 raised to the power 26. I can apply the law here that the bases are same and we can subtract the powers. And rest I can solve like this. 25 plus 5 plus 1. Similarly, in the denominator, for these two I have applied the law. So I am left with 25 plus 5 minus 1. Now here I am left with 5 raised to the power minus 1. And in this bracket we have add all these terms. 25 plus 5 30 and 30 plus 1 is 31. And in the denominator we have 30 minus 1, that is 29. Now 5 raised to power minus 1, to make it positive, make the power positive, I can bring it down in the denominator. That is 31 divided by 5 multiplied by 29. And if you multiply 5 by 29, you see that you will get 145. So which is same as your RHS, and hence we have proved this. So these are some of the problems which are based on your laws of exponents. So you need a lot of practice for these questions. Now exercise 1.6 of NCERT is a very small exercise which with very simple questions that you can do in your homework.